So this paper is about a methodological issue in text-based causal inference. So in causal inference settings, we typically want to consider the effect of some treatment on an outcome variable y. And to give an example, this could, for instance, be the effect of deregulation on child poverty. And we typically quantify this using the average treatment effect. And since we typically cannot carry out randomized controlled experiments, we have to work with observational data and control for different kinds of confounding variables. So this could be observed confounders and also unobserved confounders. So what can we do if we have unobserved confounders? So recently there is a line of work trying to use text as a proxy for unobserved confounders. So the recent paper by Keith and colleagues gives an introduction to this line of research. So then obviously the properties of the text are going to be very important. And in this paper we are interested in the problem when the treatment variable affects the text itself. So this could, for instance, mean that the treatment is directly mentioned. So why does this matter? Well, in this case, if the treatment affects the text, then as we say, the text is a post-treatment variable. And as Pearl and others have shown, conditioning on a post-treatment variable in causal inference will lead to a wide range of theoretical problems with identifiability and practical problems with estimations. If we use procedures to compute the causal estimates, then the propensity scores will be incorrectly estimated because the treatment is directly visible in the text. So then in order to be able to proceed, we need some way to get rid of the effect of the treatment variable on the text itself. And in the simplest case, we have a property that we call separability, which simply means that the treatment affected parts of the text are localized to some individual passages. So then we can simply try to remove those passages. And in this paper, we simply assume that this can be done. For instance, that we have a domain expert that can manually go through all the passages and take away the treatment-related passages. Alternatively, that we have a perfect automatic procedure that can take away the related passages automatically. So this in practice means then that we remove this edge from the causal graph that goes between the treatment variable and the text or its representation. To illustrate this problem, we carried out the simulation using the framework set out by Daoud and colleagues. Away from the experiment is that if we are not careful and if we apply the text-based causal inference methods naively, then the estimates will be way off the mark. On the other hand, if we are careful and get rid of the treatment-related passages of the text, then the estimated causal effects will be much closer to the true effect. So this concludes our presentation, and the main takeaway is a recommendation for the community that we need to be careful when applying text-based causal inference so that we don't get the leakage from the treatment variable into the text. This problem is quite likely in practice that in many use cases the text might contain some information about the treatment. In order to proceed, we try to get rid of this effect of the treatment on the text, so that in the simplest case we simply want to remove the passages that are affected by the treatment. And as we have seen in our simulation, if this is done carefully, then we can carry out the causal estimates properly. But if we are not careful and we leave these treatment-related passages in the text, then the estimated causal effects will be way off the mark. So in this work, we have simply assumed that we can carry out this distillation, as we call it, but in future work, we want to look at to what extent this can be done automatically.